Hi everyone. Today we are going to study Euler graphs and operations on graphs. So, what is an Euler graph? If some walk in a graph contains all the edges of the graph, then that walk is called an Euler line, and the graph containing an Euler line is called an Euler graph. So basically we know that a walk is an alternating sequence of vertices and edges such that no edge is repeated. In a walk we are allowed to repeat vertices, but we are not allowed to repeat edges. And any such alternating sequence which has vertex, edge in such a manner that an edge that appears in between two vertices is incident upon those two vertices is called a walk. So any such graph which has a walk which includes all the edges of the graph, because we all know that in a walk there is no such condition that the walk will have all the edges of the graph. A walk may have just a few vertices or edges of the graph. It is not compulsory for any walk to contain all the vertices and all the edges of a graph. But a walk which contains all the edges of the graph is called to have an Euler line. Such a walk which contains all the edges of the graph is called an Euler line, and then any such graph which contains an Euler line is called an Euler graph. Of course, if you're having a walk, then by the very definition an Euler graph is always connected, because a graph is having a walk and that walk is an Euler line. So by its very definition, an Euler graph is a connected graph. You cannot find an Euler line in a disconnected graph. Now let's look at the example of an Euler graph. If we consider this particular graph, now let's find out if this is an Euler graph or not. For this, we will have to first find out whether it contains an Euler line or not. That means basically we have to find a walk which contains all the edges of this graph. So let's start with the vertex B. We start with vertex B and travel along edge 3. From there we reach vertex C. From vertex C, we travel along edge 6 and reach vertex D. From vertex D, we travel along the edge 5 and reach vertex E. From vertex E, we travel along edge 4 and reach back to vertex C. From vertex C, we travel along edge 2 and reach to vertex A. From vertex A, we travel along edge 1 and then reach to vertex B. So here you can see this is an alternating sequence of vertices and edges which we call a graph, which we call a walk, and this walk contains all the edges of the graph. There are 1, 2, 3, 4, 5, 6 edges in the graph, and all these edges are included in this walk. Edge 1 is here, edge 2 is here, edge 3 is here, edge 4 is here, edge 5 is here, and edge 6 is here. So this walk contains all the edges of the graph. Hence I can say that this walk is an Euler line, and hence this graph contains an Euler line. So I can say that this graph is an Euler graph. Now let's look at the operations on graph. There are three basic operations that can be performed on a graph. They are union of graphs, intersection of graphs, and ring sum of the graphs. So we will start with the union of graphs. What is the union of two graphs? The union of two graphs G1, where graph G1 consists of vertex set V1 and E1, and graph G2 consists of vertex set V2 and E2, is another graph G3 written as G3 equals to G1 union G2, whose vertex set V3 is equal to V1 union V2 and edge set E3 equals to E1 union E2. So basically, in a simple language, a union of two graphs is nothing but the union of all its vertex set and the union of all its edge set. So if I name the graph formed after the union as G3, so this G3 will contain all the vertices of G1 and G2 and all the edges of E1 and E2. Let's look through an example. Here we are provided with two graphs G1 and G2, and we have to find the union of these two graphs G1 and G2. You can see these are the vertex and edge. This is the vertex and edge set of G1, and this is the vertex and edge set of G2. Now the third graph G3, formed by the union of G1 and G2, will contain all the edges of G1 and G2 and all the vertices of G1 and G2. If there is any common edge or vertex between these two graphs, then it will not be repeated. It will come only once. So here you can see there are two common edges and vertices between these two graphs. Vertex V1, V2, V3 are common between these two graphs, and edge A and C are common between these graphs. So we will write vertex V1, V2, V3 and edge A and C only once. So first of all, we have copied down the common vertices and edges V1, V2, V3, A and C. Then you can copy all the vertices and edges of this graph. Like here, this shows all the vertices and edges of graph G1, right? So this particular portion shows all the edges and vertices of graph G1. Then we will add or merge the graph G2 into it. So this portion has to be copied because this is the common portion. We have to copy this portion. So this portion is the graph G2, which has been merged in graph G1, and hence we get a union of G1 and G2. So this is called the union of two graphs. Now let's find out the intersection of two graphs. The intersection of two graphs, denoted by this symbol G1 and G2, is a graph G4 consisting of only those vertices and edges which are common in both G1 and G2. So if we are provided with two graphs G1 and G2, then a third graph formed by the intersection of these two graphs would contain only those edges and vertices which are common in both G1 and G2. This is graph G1 and this is graph G2. As you can clearly see, these two edges A and C are common in both these graphs, and the vertices V1 and V2 and V3 are common in both the graphs. Further, the vertex V5 is common in both the graphs. So this is only these edges and vertices we will copy in the third graph, which is the result of intersection of these two graphs. Vertex V1, V2, V3 and V5 are common. They have been copied. Further, edge A and C are common. They have been copied. So the intersection of G1 and G2 will contain only those edges and vertices which are common in both the graphs. Now let's look at the ring sum of two graphs. The ring sum of two graphs G1 and G2, written as like this, is a graph consisting of the vertex set V1 union V2 and edges that are either in G1 or G2 but not in both. So it is basically a combination of union and intersection. That means the ring sum of G1 and G2 is such that the vertex set is union of both the vertex sets of G1 and G2, and the edge set is the intersection. The edge set contains only those edges which are either in G1 or in G2 but which are not common to both. Right? Once again I will repeat G1 and G2. The ring sum of G1 and G2 gives you a graph which contains all the vertices V1 and V2, the union of all the vertices of both these graphs. So if V1 represents the vertex set of G1 and V2 represents the vertex set of G2, then the resultant graph G3 formed by the ring sum of G1 and G2 will contain a union of the vertex set V1 and V2 of the graphs G1 and G2 respectively. And the edges in this resultant graph are those edges which are either in G1 or in G2 but not in both. So basically edges are those edges which are not common in both the graphs. So again we will look at the same example of the graphs of G1 and G2. So here is G1 and here is G2. Now the vertex set is the union of both the edges. So we will copy down, the vertex set is the union of both the graphs. So we will copy down all the vertices V1, V2, V3, V4, V5, V6. right? We have copied down all the vertices from both the graphs because the resultant vertex set is a union of both the vertices of both the graphs. So v1, v2, v3, v4, v5 and v6 we have copied here. v1, v2, v3, v4, v5, v6, and the edge set in the resultant graph will contain only those edges which are either in G1 or in G2 but not common in both. So simply we have to discard those edges which are common in both. We can clearly see that A and C are the edges which are common in both the graphs. That means I will discard these two edges. Other than these, I'll keep all the edges. So you can clearly see A and C are not here, rest all the edges are included in the resultant graph. So this is how you find the ring sum of two graphs. Now there are some points, important points related to these three operations. First of all, these three operations are commutative. That is, the union of G1 and G2 is equal to the union of G2 and G1. The intersection of G1 and G2 is equal to the intersection of G2 and G1. And the ring sum of G1 and G2 is equal to the ring sum of G2 and G1. Also, if G1 and G2 are edge disjoint, that means both the graphs do not have any edge in common, then the intersection of G1 and G2 is a null graph, quite obviously, and the ring sum of G1 and G2 is the union of G1 and G2.